Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! We're back to R300 world, doing some power supply mods and testing on the early version of the R300. And I'm going to split these revisions down the middle because there's too many variations of this amp to go over each one individually. And so we're going to split them into early and late. The early is defined as the power board in the corner up by the power supply plug-in point has a 220 UF cap. The late one has a 100 UF in that corner, and it's got two connectors to the choke that has coil written on the board. So if it doesn't have coil on the board and it's got a 220 UF cap, this video mod applies to your amp, and we already did one for the later. Doesn't matter if they've got delay boards in them or not, we're pulling those out. And then it doesn't really matter whether it's got the extra capacitor on the board. As far as this video and what we're doing, doesn't matter. They're going to be one and the same. So I did run into some other issues that I'm going to cover at the end of the video, but let's get into testing this before and after, and then doing the power supply mods to make this amp reliable. Okay, so here we are with the early model on the Analog Discovery 2 before we do any work on it, and I just wanted to test the performance. We're using the tubes that were in the other amp so that we're comparing apples and apples, just to see if there's any difference between the two versions. And I also put the tubes in the exact positions that were good in the other amp. So here at 1 watt, we got a 0.5% distortion. At 2 watts, we're right at 1% distortion. If you kind of split the difference, it's about maybe 2.5 watts, depending on which channel you look at. Then here at 5 watts, definitely are going past 2% distortion, which is kind of my threshold, because here we're probably starting to clip the amp because we're hitting 3% at 6 watts. So I would say this is a 5 watt with the Willsenton 300B tubes and all the Willsenton driver tubes, and this is with 5U4G rectifier tubes. With the 5U4G rectifier tubes, we're seeing 415 volts on the plate of the 300B tubes, and given its fixed bias, that's what we're seeing across the tube, which is pretty hot for a 300B. And then we got negative 90 volts of bias, which means it will need 180 volts peak to peak swing out of the driver stage to actually drive these to full power. I'm not sure if the driver or the output tubes clipping here that we're seeing that we're getting this much distortion past 5 watts. So let's look at the scope. Okay, this is the square wave at 1K hertz, and both channels showing the pretty much the exact same square wave. You can see the red and blue are the two different channels. So let's now see what it does at 10K compared to the other amp. We're seeing the same wonky square wave. And so no difference between the two amps on that front. So the last thing I want to do here is I want to shut the amp off, and we're going to swap the two input tubes and see if we have the big change in performance that we saw in the other amp, which as an end user, people would have no way of knowing whether the tube should be in the left or the right socket without some test equipment like we're using, which honestly isn't something that a user of an amplifier should be required to own to get decent performance out of it. So let's see here. We're swapping the tubes right now. The other thing that seems a little odd while this is warming up, it's only running about 55 volts on the plate of the 6SL7 with a 0.5 volt of cathode voltage, which is the bias of the tube. So that would explain the high input sensitivity that it has, and it is using a direct coupled cascade driver setup where the 6SL7 is driving the grid of the first stage of the 6SN7, and then that's capacitor coupled to a cathode follower triode that then's feeding the 300B amp. Interestingly, there is something different between these two amplifiers, because when I swap the input tubes on this amp, it doesn't change anything. Where, if you remember, when I swapped those two tubes in that other amp, there was a pretty massive difference between the two tubes. So I'm going to need to dig into that more and see what's going on. So, like I said, I'm going to need to compare the voltages in the two amps and see if somehow something's different between the two of them, because this one's behaving differently than the other one. And then we'll go back here, and once more, square waves look exactly the same. That didn't change. Swapping the two tubes. We go back to 1K, get a pretty reasonable looking square wave. There's a little bit of ringing, that doesn't really bother me. So, not sure why that other amp had a just drastic difference in performance when the two front end tubes were swapped, but on this sample, it doesn't make any difference. Very interesting. Well, anyway, we've got a baseline now on this amp. Let's go work on the power supply, and I will show you what we did there. Okay, so the first thing I'm going to deal with is the wiring that's underneath this board. So take the two screws out. You're going to have to cut a bunch of wire ties and stuff to get this where you can like lift this board up like this. But then we're simply going to come in here and clip that one wire off. And then trim it up. Make sure there's nothing sticking out. Then you want to make sure too that you have this wire identified, because we're going to be tapping into this wire later. And for now, just pull this guy back up like that, and you can screw this board back down in place, and we are done with what we need to do underneath that board. And eventually this wire up here is going to come over and connect up to our tag strip that we're going to put up here in the front. So the next thing you want to do is this red wire here that was connected from this pin to that pin. We're going to be connecting pin 3 to pin 3. So go like this, go across there. And while you're soldering into this lower hole, which I soldered both these into the lower hole, you're going to take this choke wire and move it from this capacitor positive over to here. And again, we've already disconnected this wire that used to go to the capacitor, and now we're going to be connecting it somewhere else here in a minute. So the pathway again is you have pin 3 connected to pin 3. You have the choke connected to pin 3. And then we're going to come in here and solder a diode across here. It's going to look like that. And then we're going to do the same thing over here. We're going to solder another diode from pin 8 to pin 3, just like that. And then the last step is going to be, I'm going to use a little PTFE tubing on this, but we're going to put this capacitor from pin 3 over here to this ground on this big capacitor, and then fashion it so that we can put a little contact cement on it and then put a wire tie around this whole thing to attach this 33 UF cap right here. And this will be our first capacitor in the power supply that the rectifier tubes see. So let me get this stuff soldered in place and it's all attached, and we'll move over to attaching the wires to the tag strip and we'll be done. Okay, so we got our diode soldered from pin 8 to pin 3. This red wire here, I'm going to bundle back up now, comes across and goes over to pin 3 here. We've got the diode that goes from pin 8 to pin 3 on this rectifier tube. Then this is the output from both rectifier tubes tied together from pin 3 to pin 3. This is going to be the first cap now. Instead of this 330 UF, we have the 33 UF. And it's grounded here to this terminal, ties to this terminal. Then we brought this wire from the choke also over to this terminal. So this is the output of both rectifier tubes, and it runs down this wire here. I know there's a ton of red wires, but another red wire over here to the choke. Then it comes out of the other side of the choke to this terminal right here. Then we have this 220 UF cap that is the second cap after the choke. And then it goes on to power the front end of the amp through these other caps and resistors. So then we're going to pull this red wire here up to this little 3-terminal tag strip we just installed. We bent the ground over because we're not going to be using it. This was the original wire that went from one positive of the output transformer to the other positive. We cut it and then we soldered it to this tag strip. And then this is the wire that goes to this big choke. It's going to connect right here, like that. And then we're going to put 50 ohms of resistance across here. Probably going to use 2 watt 100 ohm resistors. That'll be a 4 watts of resistance. If I remember right from the other amplifier, there's a little under 2 watts that are going to be running across it. And so 2 watt resistors will be plenty. You could put a 5 watt, if you just want to use a single resistor. But anyway, just want to make sure that you have a large enough resistor across these 2 terminals, and this is going to help drop the voltage down to these 300B tubes and hopefully get it just under 400 volts or right at 400 volts. And that's it. So let me hunt up a couple of resistors, solder them across here, and we'll be done with the power supply mods. So this was the final step. Solder a couple of 100 ohm 2 watt resistors from here to there. Again, this is the high voltage DC on the other side of the choke. Comes down to here. Then it goes through another resistor with a capacitor to ground. That's going to provide more filtering, and this will be a nice big storage cap for the 300B tubes. And then this 220 UF cap is between this point and ground to provide more filtering. And so we're actually putting an extra stage of RC filtering to the 300B tubes, which should help keep them nice and quiet. Okay, here we are back on the Analog Discovery 2 after we did the power supply changes. And honestly, the voltages inside didn't change a whole lot. We are putting a little more voltage to the front end, and that looks like it helped even out the channel-to-channel differences we saw before. And we've got the same 2.5 watts when we cross 1%. We're making right at 5 watts when it's going past 2%. And right here is where the amp's going to start clipping. You can see it turns up from there pretty steeply. And we're making 6 watts at 3% distortion, which is a little higher than the other amp. I need to go back and look. It's been so long. I think I added a breath of negative feedback to that other amp. And I'm going to talk to the owner of this amp and see if he wants me to change that or if he wants me to leave it alone. Because if he liked the way it sounded, I don't want to do anything that possibly could change the sonic character of it. I also want to put first the Western Electric 300B tubes in and see what that does for the distortion. And then we'll put the new old stock 6S and 7 and 6SL7s in And we might actually try them back and forth combos with the Willsenton tubes. Might go ahead and throw the 300B-Z tubes in, which usually lowers some distortion, and just see which one of these combos looks the best. We might save all of that for a final video. I think I'm going to wrap this one up here and do some final thoughts on these R300s and trying to modify them for the power supplies to be reliable. As you can see from the audio analyzer suite testing, this isn't changing how the amp functions. It's simply making the power supply reliable. So if you like the way the amp sounds as it is, these mods just make the power supply reliable by lowering the capacitance of that first cap that the rectifier tubes see. And with the mod on the early one, we're adding an actual extra stage of filtration for the 300B tubes, which is always a good thing. So one of the things I'm running into in these amps is the parts just aren't consistent from one to the other. When I was working with this early version, I was going to put some 5AR4 tubes in it, and the voltages went through the roof. And I'm like, what in the world's going on? Well, in the late version sample that I tested, the power transformer has 715 volts AC coming out of the high voltage winding. Well, on this one, it's 740. And so that pushes all the voltages up, and you honestly, I'm not going to try to run 5AR4 tubes in this early version or this sample, because I'd have to put so much resistance in the power supply that could actually negatively impact the sound and the bass response that the amp has. And so I don't know if I'm going to be able to say, hey, if you've got one that looks like this, you can do XYZ universally, because without measuring the voltages inside the sample that you have, I don't know what transformer they put in yours. And I think part of this stems from, if you're buying one from Amazon, it was likely imported to be used in the US with 120 volt primary wound power transformer, or I'm going to assume it is. If you've got one from outside the country, you bought it from China Hi-Fi or one of these other discount places trying to save a couple $100, they may be sending you one with 110 volt primaries, and I don't know how many different versions of this Willsenton actually made, whether they have a 100 volt, 110 volt, 115, and 120 volt. And for most of us in the US, our wall voltage is going to be over 120, probably 122, 123, maybe even up to 125. And that's going to impact the voltages in a tube amp because there's no voltage regulation in them. I did note that the later version has a Zener diode on the power rail going to the 6SL7 to control the plate voltage, where the early one doesn't have one. And so the plate voltage on the tubes is going to be directly related to what the windings in your power transformer are. So in this early sample, we're going to leave the 5U4G tubes in it. For one thing, the owners hadn't had any problem with it. He's got some nice new old stock 5U4Gs in it, and I'm just going to live with the fact that it doesn't have a slow ramp up of the voltage. Because we've gone to such a small first cap that's being shared by the two rectifier tubes, don't have any concerns about it arcing over or doing something crazy. And so I'm okay with using the 5U4G tubes with that capacitance. On the later ones, they have the 100 UF first cap the way we did it, and that's kind of pushing it, but it probably still would be okay. And so what I'm saying here is check the voltage on your 300B tube on the plate after you do the mods to either version that you have, and if it's over 415 to 420 volts with the 5AR4s, then go back to the 5U4Gs. And if you've already got 5U4G tubes, test your amp, check the voltage on the plate of the 300B tube, and if it's over 400 volts, especially if it's like 410 or so, don't bother trying 5AR4s because it's going to push it to 430 volts, 435 volts, which is higher than I want to see on a 300B tube. And honestly, I still feel like they probably should have cathode biased these tubes or this amp. They've got enough plate voltage where they could throw away the 70 or 80 volts or whatever that would be across the cathode resistor and would actually bring the 300B tubes down to a more reasonable voltage. And if you look at the data sheets, especially for the original 300B tubes, most of the operating points they're showing are between like 250 and 300, 350 volts. They're not talking about running these things over 400 volts. Now the Western Electric 300B tubes, they are rated to 450 volts. But I know some of like the mesh plate ones and stuff have a limit of 400 volts. So if that's the case, you have to be careful. You may have to put a dropping resistor or add some resistance. So like in this mod where I put 50 ohms of resistance with the two 100 ohm resistors in parallel, you may have to increase that to 100 ohms of resistance or 220 ohms of resistance to try to get the plate voltage down to what the tubes that you're running can tolerate. And all that said, I'm not that concerned about being a little over voltage. I found the key thing is to keep the milliamps down, but you need to know the plate voltage so you know what milliamps you can run to calculate the dissipation. Because if you're running 390 volts on the 300B tube versus 425, you can't set the bias meter in the same place because it's going to change the watts going across the tube, and that's what causes them to red plate and causes problems. So this whole thing has been a very frustrating process to me, that there's so many variants of this thing that are all called the same thing. There's nothing on the box calling it a Mark 1 or a Mark 2 or a Mark 3. It's just, hey, which one? I don't know which one I've got. And then some people ordered these things like late spring, and they're still getting the early versions. And then other people are ordered before then, and they get the ones with the delay boards in them. So, yeah, guys, I just don't know. So finally, I think we're done with the power supply things as far as I can go. And again, I can't, unless the amp's sitting in front of me, I can't tell you which rectifier tubes you can use. And I know there's people that are like, well, can I put the 5AR4s in mine and be okay without touching the inside of the amp? And I would say no. And honestly, if you don't want to touch the inside of the amp and you just want to put tubes in it as a fix, find some new old stock 5U4Gs, put them in and cross your fingers that they're beefy enough to handle whatever's inside here. But I will say, if you've got one of these early ones, like this one is, that has the 330 UF cap as the first cap after the rectifier tubes, I can't recommend using them like that. That's so far outside of the recommended capacitance that the rectifier tubes can handle. And I keep saying this, I need to do a video explaining why that's so important. And a lot of people think it's the inrush current. That's not the key thing. That's not why it's just brutal on these tubes to have that much capacitance. So maybe next week I'll try to put together a short informational video about tube rectifiers and capacitance and why it's important. So anyway, next we're going to be doing some serious tube rolling. I want to try the Western Electric 300B tubes. I want to try the 300B-Z tubes. I've got quite a few new old stock tubes I can roll into this amp. I'm going to be doing some listening tests and then give some recommendations on what I think you should be putting in these as far as tubes and what you're giving up if you're using the tubes that came in the amp versus rolling in some different ones. So anyway, next video we're going to jump more into things and be looking at the frequency response curve and the square waves and all that stuff again. I'm starting to think that a lot of that is in these output transformers that we're not going to fix, and it may just be something you have to live with if you're going to own this amp. And I'm just not willing to go that deep into these, replacing iron and everything, trying to fix these, because at that point then you're starting to get so much money in this amp that you could just go buy one that doesn't have these issues. So anyway, hope you're enjoying the series. If you are, please subscribe to the channel. Please like the video. Thanks to all you Patreon folks. Thanks to you folks that are making donations. If you find this information valuable to the stuff you own, a donation would be much appreciated. Also, thanks to folks that lend me this gear so I can bring you content about all these different amplifiers that I couldn't afford to go out and buy samples of. So until the next video, have a nice day.